For those who don't know me, I'm Grant Barnes from Auckland Council. I'll help chair the session. Just a bit of housekeeping. The end of today's proceedings, the reflections one, a slight change. What the organisers are proposing now is that the Chief Statistician, Liz McPherson, will be interviewed by Susan Wood, our MC, for a 30-minute question and answer session about what's going on in Stats NZ looking ahead to 2020. So really encourage your attendance. We'll follow shortly thereafter with a bit of a fun, I'm promised a fun session by SAS, our software providers, followed by some even more fun solicited with a bit of drinks. So that's some housekeeping. Let's get into the proceedings. This session's about access to data. Have I done something? We're right? Okay. So I guess there's another slight change. We're going to go with Keith first, aren't we? Okay, cool. Right. So access to data. So I'm working on the premise that transformation of data and information is a function of its use and its accessibility. So we're going to hear from three people at the forefront of that very thing: Lillian Grace, Keith Nye, and Jimmy O. I'm going to invite Keith up now. Keith, I asked his permission. Keith doesn't mind if I introduce him as the guy who broke the kiosk. But there's a lot more to Keith than just being a super blogger on public address. He's also has a venture called ChewyData, and he reminds me that he's doing a lot of work at the moment on data visualisation with Stats NZ. So it's my pleasure to welcome Keith to the stage. Thanks, mate.
So, I asked for a lot of data. One of the most common responses that I get to my requests goes something along the lines of, why? I can understand where they're coming from. I make some very weird data requests. Generally, they go something like, hey, can I get every measure for every item sort of from the start of when you started measuring it to the last data set you measured? Essentially, it's asking for all the data at the finest level you can possibly give me for all the time periods that you have. I was originally going to talk a bit about data formats, which is what it says in your program, but I think Jimmy's going to cover that, so I'm going to take a step back and try to answer this question of why we make such odd requests from a broader sense. And I guess the answer is data journalism. I like that answer because nobody really knows what it means, and it's not really a particularly good answer to anything because I haven't really defined the question. And in a sense, that's quite an appropriate answer for what we actually do. Unlike traditional researchers, we don't actually start out with a specific hypothesis. We don't have a specific goal in mind. Think about traditional long-form journalism. Sometimes journalists write on things that have immediate consequences. Sometimes they write about things just because they're interesting. The problem with looking for things that are interesting is that you don't know that it's interesting until you come across it. And the real kicker is, sometimes we don't even need to find that single interesting thing. Sometimes we just need to provide a pickaxe and a torch and let users find their own interesting things. The pickaxe that I'm talking about are the algorithms and the navigational tools that we build so that users can filter, can traverse, and can break down the data set for themselves. The torch that I'm talking about is the visualizations, which make it easier for users to spot and identify the particular pieces of data that they're interested in. I'm going to take you through a few explanatory and exploratory styles of visual storytelling to explain what I mean. Given the time constraints, I'm just going to blaze through them and only go and talk about two in detail. So, explanatory visualizations, when we found something interesting, we know what that specific thing is, and we're using the data to describe and to present it. So this here is, it could be aligning data to provide context. This here is a map of the Fukushima disaster. Over there on the right, we're describing a single scale of dangerous levels of radiation. And over there on the left is a map of the impact of the area of that radiation. By having the two different data sets aligned together, it helps us understand how the people in that region is actually being affected. It can also be used to break down data to provide details. This visualization here shows demographic changes in New Jersey. It uses a technique called small multiples, so reproducing the same graph many times. Once we figure out what that first map means, how it relates to the actual geography, our brains are essentially calibrated so that when we see more of these things, we can understand them better. This one is particularly interesting because it uses details and complexity to its advantage. It provides too much detail on purpose. Because our brains can't keep track of all those individual dots, it forces our brain to abstract and summarize, which keeps us focused on the big picture. So I'm going to show you this one in detail. This one is actually one of my favorite work from the New York Times, showing budget forecasts versus reality for America. We start off with a very simple line. Everything above the line are surpluses, and everything below are deficits. So you can see that's when America was in surplus. So next, we do something that's very simple. We add one line. So now we have last year's forecast versus this year's forecast. It's a very simple thing, right? You just added one thing. But what it's actually done, it's calibrated our brains to figure out what, to be able to compare different budget forecasts. And once we've done that, the real story starts. All those lines heading up, those are projections that America will be in surplus real soon. We're going to be in surplus by the 80s. Almost there, just a couple of more years. This downturn, temporary. Almost there, almost there, almost there. Until the 90s, when they finally realized, we're just not going to be in surplus. And then eventually, they were for a brief while, and then 2008. And take a guess what happens next. So this was the point, this was where they forecasted their position to be, and this was where they were. So what it actually shows is that most of the forecasts in the past 30 years were too optimistic, especially prior to the global financial crisis. This visualization is one of my favorites because it managed to build a very complex picture, America's fiscal outlooks and performance for the last 30 years, in very accessible chunks. It does this by hiding the big picture and revealing it one simple step at a time, and explaining every step along the way. Now, a traditional approach to this problem might have been to reduce the complexity. You can sum up the total error for each forecast and then draw a map of that. But if you did that, you've lost the complexity, you've lost the shape of the data, and the way people understand it is quite different because all they can ingest at that point is the thing you've given them, not the thing that it was drawn from. So I'm going to take you now through some exploratory styles of visualizations. Exploratory visualizations don't necessarily have a clear narrative, but they're not free-form either. They have a very specific way of exploring the data. Before we can actually figure out what exploratory visualization does, we have to get a basic understanding of why a user would be interested in a particular piece of data. Maybe it's about structure. So this here is a visualization of the increases and cuts in the 2012 budget. So you can mouse over each one of these things and say, hey, actually, Social Security is a large part of the budget and has increased a little bit. Core government services has decreased by quite a lot, but it's actually a relatively small part of the whole budget. So in this way, we get a broad sense of the shape and the structure of how the budget has changed. Sorry, I'm in a bit of a rush. So the next thing we're going to look for is relevance. maybe each user will actually be interested in something different, that the big picture isn't actually interesting for your user, nor the average. Maybe what they actually want, so this is from the Stats New Zealand Time Use Survey. So maybe they'd want to explore things by ethnicity, or by age, or by work status. And then you can find out things like, hey, actually, let's look at the gender differentiated time use in housework for a particular ethnicity. When users are presented with too much information, one strategy that they use is to find data about themselves. Think of this as the "I can see my house from here" effect. It's how we benchmark that, when we say on a plane and we try to find our own house, that gives us a starting point of, hey, I know where I live. If that is the place where I live, what are the things close to where I live? And they start out and navigate from there. So data in which you can allow users to find specific elements can give them a much better sense of the data, because they can have a reference point using themselves, and then they can start generating meanings and comparisons with other people based on that. So there are some other aspects of data that lends itself to exploration. So this one is a visualization of the Consumer Price Index that I built for Stats and is coming out next month. So I'm not going to start by explaining what it is. I'm just going to ask you to have a look at that and see what sticks out. What are you interested in? Say, these things here, that's sunken. Why is that sunken? This thing here sticks out. Why does that stick out? So just by mouse overing it, we know that it's housing and household costs. Let's click on it. And we can see the drivers of that. So the idea behind this is that, let me go down a little bit further. So you can see things like rates. Rates is the parts that stick out the most within this category. And these other three things are actually also increased by quite a lot. So we can go energy costs, electricity. The bulk of energy costs comes from electricity. Therefore, we get a sense of how electricity contributes to the rise in housing costs. So I wanted to end with this one because it's the best example of why we ask for all the data. We got to electricity, which is several levels down, because of something that we found interesting at the higher levels. And we did it in seconds. All this is because all the data is there for us to explore. If we did things in a traditional way, where we asked for data coming in at different levels, we would never be able to put all of that stuff together. And if it's not all together, we would never be able to navigate it, and we would never be able to find the specific things that we think now are interesting, because we wouldn't know they were interesting in the first place. We can't get here with spreadsheets. Well, we kind of can, but it would make our lives really difficult and we would start crying, so please don't force us to get here with spreadsheets. Thank you.
It's my pleasure to welcome Lillian Grace to the stage. Lillian is founder and chief of Wiki in New Zealand.
Hi, it is so fun to be around people that love data as much as I do. What do you think the dots represent? No, not population. Sorry? Not earthquakes? No.
Takes about the earthquake?
No, they are tall.
What about phone towers?
No, but getting closer and that kind of thing.
Your dairy farms.
No. Man-made tall structures.
Electricity pipelines.
They are windmills. Fun, eh? What about this one? This shows GDP per capita for OECD countries for 2012, but I've taken the country names off and just put numbers. What number do you think represents New Zealand? This being the highest GDP and this being the lowest over here. 27? Not 27? I don't have any prizes, but I'm not going to move until someone guesses it. 22? Not 22, but that's really close. 21, yeah. All right, so Wiki New Zealand is a collaborative website making data about New Zealand visually accessible for everyone. And it's filled with graphs and thematic maps about New Zealand across topics, social, economic and environmental, just anything that's relevant that we can keep as unbiased as humanly possible. And the purpose of it is to enable informed decision making in all areas and at all levels. And it came about from my experience at the think tank, the New Zealand Institute, where previously when I hadn't worked there, I didn't really know much about data, or I didn't even know what the OECD was, let alone ever having used their database. And throughout those few years that I spent there, I got to know heaps of databases, see how much wonderful data already exists that's already presented across a whole lot of sites, StatsNZ, OECD, etc. And we would go out and we would do presentations to show people our solutions and proposals. And what really struck me, what I started to notice, is that what we were showing them was new to them, even if it was in an area that they spent all their time working. And I remember putting up a chart showing that New Zealand has the highest rate of reported youth suicide in advanced countries. And I did it to a group of people that work with youth, and they were stunned. And one woman said, that graph is going to make me work harder at my job because I had no idea that was a situation. And that situation kept happening over and over, regardless of whether we were doing work in the economy or the environment, regardless of what kind of group we were talking to. And so I started to see that there was such a big gap between what was available and all the stuff that I knew existed, and what people actually wanted and what they could access and what they knew existed and could use. And the difference between data that's available and data that's accessible is quite big, because you need time and skill to access available data before you can actually do something with it. So I'm going to show you some data, and I want you to just, you can do it in your minds this time, to quickly think about what this data is telling you. And now, what this data is telling you. I used to think that people in New Zealand didn't really care about our future, apart from their own involvement in it. Totally thought that people were just complacent, cared about their own little lives. I have totally proved myself wrong with talking to hundreds, literally hundreds of people about issues about New Zealand. People really care, people really want to understand things, but they have no idea how to do it. They don't know where to go. They don't know, when they look at something, what to do with it, what it means. They don't know, usually when we see data, because it's always embedded in spreadsheets and databases, when we see it in a visual form, it's because somebody's trying to convince us of something, which is a very legitimate use of data, but not sufficient for having a well-informed country. But people really want to see it, really want to understand it. Sorry, I can't stop walking around. As people involved in collecting and disseminating data, I think that we need to think about how we think about data. What do you think when you see this slide? Sorry? Yeah. Because I think that if we have data at the centre of what we're doing, we might think, oh, how can I improve how I collect the data? How can I show it in different formats? How can I kind of improve in incremental steps what I'm currently doing? But incremental improvements don't necessarily lead to success, compared to if we actually say, what is the purpose of data? Which I believe is to enable informed decision making and to get really good outcomes. And if we place the user at the centre of the model and think about them and who actually wants to engage with the content, I think that we all end up winning because of the outcomes we get from how people use data, like how Keith's talking about. So my proposed process for how we think about data, and it's how I try and think about data, is to start at this end and to say who needs to make decisions. I would argue everyone. But then what kind of decisions do people need to make? What data do they need to make those decisions? And then how would they best interface with that data? And I think if we do those 4 things well, we can be confident that what we spend all our time and effort doing, where we direct our attention in the area of data, will be beneficial and be useful for people. A couple of days ago, I get asked for data all the time now that people know that I kind of bridge the gap between, or Wiki New Zealand bridges the gap between data that's embedded on sites across the country and how to visualize it and see it. People email me and they call me up to say, oh, do you know if I can get data on this or that? And often I can just kind of send them directly somewhere because I know how to navigate where the data is. And it was interesting, 2 days ago someone asked for some data and I didn't think it was available, but so I contacted the appropriate organisation and I was delighted to discover it is available. But I don't know how to tell somebody that they're going to have to pay $300 to get that data from a public organisation. And I just think if we care about our data being useful, we need to really think about the user, about the actual position of where the user is. Because if we're collecting data, it is a waste of time unless somebody is doing something with it. That's all. I could go for hours, but I shall stop.
I'm a PhD student at the Department of Statistics at the University of Auckland, and my PhD is basically on making open data more useful. And my thought when I started the PhD was, well, there's all this data out there. I know it's out there somewhere. I'll just take it and create nice visualizations of it. But as you do as a PhD student, you start with a literature review. And when I did a literature review of open data in New Zealand, I found that actually, primarily with format issues, that it's actually not that easy to use. And I need to do some work to get it to a usable form before I can do cool stuff with it, like creating visualizations. And one of the main reasons for that is because I'm a technical user. And so a technical user is one who prefers to write scripts so a computer can automatically carry out tasks. That means I'm not going to go there and manually select data and manipulate it and produce graphs. I want to write a script and have the computer do everything for me. And for that, I need the data to be machine readable. And ideally, I also need the data to be accessed in a machine readable way. And when I did that literature review, I found that a lot of the organizations don't go quite to the extent that I would like them to be. And I can totally accept that because technical users are not a majority in the users. I suspect that most users probably do want to open the data up in Excel and do things in Excel manually. But I would like to see provisions made for technical users because the advantage of using scripts to do things is that if, for instance, the data gets updated, you just run the script again. You don't need to put in another hour or two to redo it all. You just run the script again, it takes a few seconds, and now it's up to date with the latest data. So by making things more useful to technical users, you're going to see data being used on a continual and up-to-date basis, as opposed to more manual approaches, which are often one-offs that go out of date in a few months or a few years. So I'm going to give 2 specific examples of organizations and how they do things and how that's good and bad. The first one is going to be the IRD. So the IRD has this web page, the tax statistics sitemap, the simple HTML web page, a whole lot of links to all the data sets they have. And this is actually good. Why? Because it's very simple. It's very simple, so it's very easy to code the computer to follow all these links and find all the data sets. Right? It looks complicated, but actually, because it's such a simple process, I can program a computer to find all the data sets and get it automatically. So this, despite its simplicity, is very useful. When you actually click through, this is what you got last year, and I'll show you what you get this year and how that's changed. But last year, if you went through, you got this nice static graph, very simple graph of the data, an HTML table of the data, as well as a download link to an Excel spreadsheet of the same data. And if you go there now, this is what it looks like. You have an interactive graph using something called high charts, and a download link to the Excel table. You no longer have that HTML table. And unfortunately, if anyone from IID is here, I'm sorry to break it to you, but I actually prefer the older version. Why? Because that HTML table. An HTML table is in a nice plain text format. I can get a computer, easily scrape that data off and use it. It's nice and structured, it's plain text, not behind a proprietary format, very easy to access. Whereas now I have to go and grab an Excel data spreadsheet, use a separate program to access the Excel spreadsheet and convert it to a plain text before I can do anything with it. But I can do that though, so it's not that bad. What's perhaps more important is the internal structure of the data. So if you have a look at that table, what you see is you see a single row of column labels and a single column of row labels. It's a very simple format, and because of it, it's machine readable. A computer can understand this, and I can process it automatically very easily, produce graphs like that, produce all of the other graphs, and combine it with other data sets very easily. So IID overall is actually pretty good. Despite its simplicity in this, and also in the simplicity in the HTML table, it's actually very useful for a technical user. So as long as they go back to producing HTML table, I'll be very happy with the IID. The second example is Statistics New Zealand. So they have this NZ Stat, which is new, but it's quite similar to what they had before with InfoShare and Table Builder. Now, the first thing you notice about this is that it is an interface purely for humans. A human has to go in and click through all these things, through the categories, in order to access the data. A computer, I cannot get a computer to automatically script and get all the data automatically for me. They are looking at creating an API, which would allow a computer to script access it, but it's not available yet. So if I want to do this now, I have to go there manually and get the data. And so again, the point of script-based approaches is that if I get a new data set, I can just have it update automatically. But if I have to do a manual step to get the data in the first place, that just adds a big speed bump to the whole process of keeping everything up to date with the latest data. So this human interface, not that helpful for a technical user. And with relation to the data itself, the internal structure of the data, you see multiple rows of column labels. This is what I call a hierarchical table. And a human can understand that. We understand that all those things down there belong to male. But for a computer to understand that, it needs to somehow figure out all these positional cues and the relative positions of these cells in order to understand the structure of the labels and therefore understand the data. That is very difficult for a computer to do, making this not machine readable, despite the fact that NZStat actually allows you to export this into a CSV file. So the external file storage format, plain text, that's good. Internal format, not machine readable, so it actually doesn't help at all. So I'm a PhD student, so by definition I'm insane. So I actually have written a program that does automatically convert hierarchical tables like this into a machine readable format. But that took a lot of time, and that's a lot of time that I could have spent actually looking at the data and producing things that could be more useful and perhaps affect your decisions and your life and so on. So making things not machine readable is a big barrier to making things more useful for the general public. So if you have a look again at what I've been saying, I haven't been asking for complicated things. It's simple things that will actually help technical users a lot. Complicated things are great as well. So if you give me the entire data set, all the data in a nice structured format with all sorts of metadata and in a nice format like XML or something, that's great. I can use that as well. But if you don't have the resources to do that, all I want is something simple. Just simple hyperlinks will do. I can crawl through that with the computer. Simple text file will do. I don't need things broken down into hierarchies. I just want the dump of the data, and then I can have a computer automatically process it all and get useful things out of it. So that really is my perspective on the open data as a technical user. I just want things to be released in a simple format so I can actually go through it with the computer.